For this lesson, you need to keep in mind how we were factoring by grouping, where we were taking out the greatest common factor after we grouped together our pairs, and then we found that we had common binomials, so we factored those out. That same process is going to apply whenever we're factoring trinomials, when you have a coefficient other than 1 in front of your x squared. So these problems are going to be just a little bit different than the ones 2 lessons ago where the coefficient was 1. When the coefficient was 1, we were just finding the factors of c, which was our last term, whose sum was b, the middle term. Well, in this case, we have to take into account that our a value is no longer 1. Okay, our a value is 5. So what we have to do, and it's listed here in the description of this problem, is we actually have to multiply a and c together. Think back to the 2 lessons ago when this was 1. If I multiply 1 times 2, I got 2. So we didn't have to worry about that multiplication because multiplying by 1 doesn't change the value. Now that we have something other than 1 in front of the x squared, we have to multiply that number by c. So we have to multiply the 5 and the 2 together. So watch closely as they guide you through this problem on how to find the factors of 10, because that's multiplying a and c together, whose sum is 11. So still the same basic principle, we just have to make sure we multiply first.
Step 1. Find factors of a times c that have sum b. Since a times c equals 10 and b equals 11, find positive factors of 10 that have sum 11. The pairs of factors of 10 are 1 and 10 and 2 and 5. The sum of 1 and 10 is 11. And the sum of 2 and 5 is 7. Since the sum of 1 and 10 is 11, use that pair of factors. Step 2. To factor the trinomial, use the factors you found to rewrite b times x.
So basically what we're going to do is we're going to take this trinomial and we're going to leave the a part, the ax squared, and the c alone. We're just going to break the bx apart, okay? Now we know which 2 numbers to use. We know we need to use a 1 and a 10, so that's how you get 11. So we're just going to break this apart into a 1x and a 10x, because 1x plus 10x is 11x. So that's what finding the factors does for you. It helps you to break apart or rewrite the bx of your trinomial.
Rewrite b times x. In this case, write 11 times x as 1 times x plus 10 times x. So you can rewrite 5 times x squared plus 11 times x plus 2 as 5 times x squared plus 1 times x plus 10 times x plus 2.
A good practice on that to make sure that you don't make mistakes is to rewrite this before you start finding your factors. Rewrite your first term and then give yourself 2 blanks and then rewrite the third term. Just remind yourself that you've got to rewrite this into a polynomial with 4 terms because you've got to break apart the bx. And we just use the factors that we found at the beginning. 1 and 10, when you add together, give you 11. So we're just kind of working backwards.
Factor out the greatest common factor of each pair of terms.
This is your factor by grouping.
The greatest common factor of 5 times x squared and 1 times x is x. The greatest common factor of 10 times x and 2 is 2.
Factor by grouping. Group the first 2 and group the last two and take out their GCF.
Now use the distributive property to find the factors of the trinomial. So you can factor the trinomial into the quantity x plus 2 times the quantity 5 times x plus 1. Will the process still work if you rewrite b times x as 10 times x plus 1 times x, switching the order of the terms?
Now let's back up and recap real quick before we go to that question. This is just factoring by grouping again. Once you've taken out the GCF for each one of those binomials, you notice that your parentheses, your binomials you have left over, are the same. So you factor that out, or you remove the 5x plus 1, and the x plus 2 is what you have left over. So this is taking into account the factoring the trinomials from the beginning and factoring by grouping and just merging the two concepts together. Now, back to this question that they asked, will the process still work if you rewrite this? Basically, like she said, you're just switching these terms. Instead of having the 1x and then the 10x, can you rewrite it the other way? And think about it. What did we do after we rewrote the trinomial? Well, we just factored the GCF from the first two and factor the GCF from the second two. So look at them. Does 5x squared and 10x, if I put a parenthesis around those, do they have a GCF? And they do. Hopefully you can identify that. They have a 5 in common. They also have an x in common. Now the question that a lot of people have is, well, what do I do here? The x and the 2 have nothing in common. Well, any number and or variable will have something in common, and that will be 1. Anything can be multiplied by 1 and remain the same. So their GCF, because there's not one, in a sense, is 1. So it doesn't matter if you switch those two terms or not.
Yes. You can rewrite this alternate expression as 5 times x times the quantity x plus 2 plus the quantity x plus 2, which equals the quantity 5 times x plus 1 times the quantity x plus 2. This expression is the same as the expression you found before, but the terms are switched.
And we know that multiplication is commutative and associative, so we can change the order of the grouping if necessary. We change the order of our parentheses, but it would still give us the exact same trinomial if we were to work backwards and check our answer.
Now it's your turn.
All right, so think back to the whole process of that last example. The first thing you've got to do is multiply your A and your C together. Okay, multiply your 3 and your 2 together and find the factors of 6 whose sum is 5. Create that table. Write the 6 in there and think of all the factors of 6 and then add those factors together to find the one set of factors, the one pair that will add equal 5. And then start factoring by grouping. Please use the last example to follow through with this practice problem. Now, I'm not giving you the answer choices like the other problems. I want you to factor through this. So pause the video and factor this trinomial. Okay, hopefully you've got your answer there. The correct answer to this is 3x plus 2, that binomial, times the binomial x plus 1. Obviously, if your binomials are switched, not a big deal, but you still get the same answer. You just have to make sure that you're factoring out the greatest common factor. Now, here is the table that I told you to create. There's only 2 sets of factors for 6, 1 and 6 and 2 and 3. 2 and 3 were actually the two numbers you had to multiply together originally to even get the 6. That's your A and your C. So sometimes it works out that the two numbers you use at the beginning are the two numbers you need. Not all the time. But those are the two factors that work, and they've broken it down here for you. They've rewrote the bx, the middle term, into the 3x and the 2x. Now notice the reason they put the 3x first is because they were pairing it up with the 3x squared. Obviously they have a 3 in common. And the 2x squared matches up with the 2 because they have a 2 in common. So they purposely write those so that they can factor out the GCF the easiest way. And that would be my suggestion. Make this easy on yourself. Factor out the GCF of each one of those binomials, and then your binomials are identical, x plus 1. So what you have left over is 3x plus 2. All right, let's look at another example.
In this problem, you will apply the process of factoring trinomials. The area of a rectangle is 2 times x squared minus 13 times x minus 7. What are the possible dimensions of the rectangle? Use factoring.
Now we're using factoring and we're trying to find dimensions, but what I really want you to focus on here is this example has negatives. And so that makes a difference when trying to come up with your GCF, when you're trying to come up with your factors before you even have to do the GCF. So pay very close attention to how they factor this trinomial.
How can you find the dimensions of the rectangle? Factor the rectangle's area as the product of two binomials, one of which is the width. The other must be the length, since area equals length times width. Step 1. Find factors of A times C that have sum B. Since A times C equals negative 14 and B equals negative 13, find factors of negative 14 that have the sum negative 13.
Now notice, all they did was multiply 2 and negative 7, because you have to use the sign that falls in front of the number. That's where the negative 14 came from. So factors of negative 14 whose sum is negative 13. So you got to think of all your factors of negative 14 and then add them all together to find the one that works.
The pairs of factors of negative 14 are 1 and negative 14, negative 1 and 14, 2 and negative 7, and negative 2 and 7. 1 and negative 14 add to negative 13. Negative 1 and 14 add to 13. 2 and negative 7 add to negative 5. And negative 2 and 7 add to 5. Since 1 and negative 14 have a sum of negative 13, use that pair of factors. Step 2. To factor the trinomial, use the factors you found to rewrite b times x.
Just like you've been doing all the other problems, except this time focus and pay attention on what they do with all of the negative signs.
Rewrite b times x. In this case, write negative 13 times x as x minus 14 times x. So 2 times x squared minus 13 times x minus 7 can be written as 2 times x squared plus x minus 14 times x minus 7.
So if you noticed, it was a positive 1, so that's where the 1x, positive 1x come from, and a negative 14, so that's where the minus 14x comes from. So pay close attention now how they group and factor out the GCF.
Factor out the greatest common factor of each pair of terms.
Now notice, this is extremely important. Negative 14 and negative 7. Negative 14 and negative 7 have a negative 7 in common. They're not just taking out a 7, which would make that a plus sign. They're actually taking out a negative 7, because dividing both of these terms by a negative number is what will change them to a positive. So be very careful with that.
Then use the distributive property to get the factors of the trinomial. So the possible dimensions of the rectangle are 2 times x plus 1 and x minus 7.
You cannot do this unless you have taken out a negative 7. Your binomials will not look the same, so be very careful with that.
Now it's your turn.
All right, so we're going to go through this problem in class, but I want you to go ahead and write this one down. This one actually has plus signs, so this is going to be similar to the first one. and we'll discuss it in